Okay, so let's get started. So firstly, hello and thank you for joining this webinar today. This is the fourth and final part in this webinar series where we're going to be looking at each of the four domains of the AWS Certified Solutions Architect Associate. Now, the ultimate aim of this series has been to provide you with more of an in-depth and guided understanding as to the various topics and services that you should be familiar with when studying for the exam. Now, today's focus is on domain 4, designing cost optimizing architectures, and it's worth 18% of your total score. Now, it's the lowest percentage contribution out of the four domains, but it still needs to be given just as much attention as the other domains. Now, if you have any questions as we go through this webinar, please use the chat window to submit them, and we'll get to as many of them as we can as we go through our Q&A section towards the end. So before we get into the meat of the content, let me start by introducing ourselves on the panel. So today I have back with me Stephen Cole, our AWS certification specialist here at Cloud Academy, who joined me when we covered domain 2. So hello, Stephen. Thank you very much for coming back today.
Good morning, good day. It's good to be here, and it'll be kind of fun to talk about this.
Yeah, it's great to have you on the call, so thank you. And of course, myself, I am Stuart Scott, the AWS Content and Security Lead here at Cloud Academy. So looking at the agenda for today, we have three subdomains in domain 4, these being identify cost-effective storage solutions, identify cost-effective compute and database services, and design cost-optimized network architectures. So let's begin with 4.1, identifying cost-effective storage solutions. Now, firstly, I think we should talk about Amazon S3. In the exam, you'll certainly be tested upon your knowledge of S3, and the cost implications are likely to arise as a part of that. So you need to be familiar with the different costs associated and how to optimize these costs when working with S3. So the main focus here on this slide is the different AWS storage classes, which each provide different benefits from both performance and cost perspective. So you need to have an understanding and familiarity with the different classes that you can see on the screen. S3 Standard, Intelligent Tiering, Infrequent Access, and One Zone Infrequent Access. You should look into the different scenarios of when you might use each of these classes in a production environment and how this affects your pricing as well. And essentially, if you look at the table there, it gets cheaper from left to right. So S3 Standard is the most expensive, and S3 One Zone Infrequent Access is the cheapest. So when answering questions relating to costs on S3, look out for keywords and clues in the question. For example, you might see something that says access to your data will be minimal. So that leads you to lean towards infrequent access. If the data is not being accessed as much, then infrequent access would be better than S3. What are your particular thoughts around this, Stephen? Any kind of key points to point out?
Well, towards the bottom of your slide, you see those life cycle rules, really understanding that there's ways to automate the moving between the different classes so that you don't have to do it yourself. I mean, part of what makes it a more cost-effective thing is that I am not being paid to move this stuff around. So I think that's very important to remember.
Definitely, life cycle rules is key. Like you say, to help optimize your costs, especially if you're going from something like S3 Standard to Glacier, you can have a significant saving. And something else as well I just thought of that I haven't got on the slide, but it's worth mentioning, is versioning. Now, this won't actually optimize your costs, but it will increase them. So just be aware of that. Now, with versioning enabled on a bucket, every time a change is made to an object in that bucket, it will be saved as a new version. So, for example, if you had a document and then modified it, it would be saved as a new version of that same document, meaning you would be storing 2 copies and therefore taking up twice as much storage space, which you will be charged for. So if multiple changes are happening to lots of objects in a bucket with versioning enabled, your storage costs could start to rapidly increase. So that's something to bear in mind as well. if you see anything on the exam regarding that. And so following on from Amazon S3, we have S3 Glacier. And again, this has its own storage classes offering different performance and costs again. But this time we have the S3 Glacier class and S3 Deep Archive. Now, out of all the different storage classes between S3 and Glacier, Deep Archive is by far the cheapest. Now, because Glacier is used as a cold storage option for your data, it does not provide instant instant retrieval access like S3 does. And as a result, there's different options for you to retrieve your data when you need it. And each of these retrieval options do obviously come at a separate cost. And you should be aware of these different retrieval options when working with data retrieval for cold storage. So as you can see on the screen now, we have expedited, standard, and bulk. Now, expedited allows you to retrieve your data in 1 to 5 minutes, providing that request is less than 250 meg. And this is the most expensive option of the 3 options. Standard retrievals take between 3 and 5 hours, regardless of how much data you're trying to get. And then finally, the bulk option, and this is a great option if you're trying to retrieve petabytes of data at a time, and this offers the cheapest retrieval option of the 3. So definitely look into the different use cases of when you would use these different retrieval options. Anything
Exactly.
to add there, Stephen, about the use of Glacier and S3?
No, I mean, other than, I mean, you pretty much said it, but you know, if you look at the 3 classes, expedited, standard, and bulk, the faster you want it, the quicker that you need it, the more expensive it is going to be. And you just need to pay attention to that in the questions, because if you see in one of either the question itself or one of the distractors that says, hey, time is important, or we have to keep track of certain costs or be mindful of certain costs, the faster you want it, the more expensive it's going to be, and that's going to impact the answer.
And that's kind of a general rule across a lot of these elements when it comes to cost,
Exactly.
isn't it?
Absolutely. I mean, it doesn't matter if we're talking
Okay, so
about any of this, so it's great.
that's a very good point. So moving on to EFS. So for those that are not too familiar with EFS, it's essentially a fully managed, highly valuable and durable storage service that allows you to create shared file systems. And this has become a very desirable storage solution for a wide variety of workloads and use cases, typically because it can meet the demands of tens, hundreds, or even thousands of EC2 instances concurrently. Now, much like Amazon S3 and Glacier, there's different storage classes again with EFS. Not as many, however, but they can still help you to save a lot of money if they are used correctly. And there are currently 2 different storage classes, these being EFS Standard, which is the default storage, and EFS Infrequent Access, which is EFS IA. Now, as you can expect, the EFS IA storage class is designed for files that are accessed less frequently than those that are recommended for the standard storage class, and as a result, a considerable cost saving can be achieved, sometimes up to 92%, which is quite a lot. The result of the cheaper storage, however, means that there is an increased first byte latency impact when both reading and writing data in this class when compared to that of standard. So just bear that in mind when you're using that. Now, the costs are also managed slightly differently. When using IA, infrequent access, you are charged for the amount of storage space used, which is cheaper than that compared to standard. However, with EFS IA, you are also charged for each read and write you make to the storage class. And this helps to ensure that you only use this storage class for data that is not accessed very frequently. For example, you might have data that might be required for auditing purposes or historical analysis. So that would be a better storage class option to use for data such as that. Now, EFS also offers lifecycle management, and when enabled, EFS will automatically move that data between the standard storage class and the EFS IA storage class. And this is similar to the lifecycle rules on S3 as well. Now, this process occurs when a file is not being read or written to for a set period of days, which is configurable again. And your options for this period range include 14 days, 30 days, 60 days, or 90 days. Now, depending on your selection, EFS will move the data to the infrequent access storage class to save on cost once that period has been met. However, as soon as that same file is accessed again, the timer is reset and it's moved back to the standard storage class. You should also be aware of a couple of different throughput modes that it has: bursting throughput and provision throughput. And again, with all these different options that are on the screen, there's a different cost element depending on which one you select. With the bursting throughput mode, which is the default mode, the amount of throughput scales as your file system grows. So the more you store, the more throughput is available to you. And using the bursting throughput doesn't actually incur any additional charges. However, provision throughput allows you to burst above your allocated allowance, which is based upon your file system size. But this option does incur additional charges, where you'll need to pay for any bursting activity above the default capacity allowed from the standard bursting throughput. Now, I've covered quite a bit there on EFS. Is there anything else you want to add on that, Stephen?
I think mostly for the exam, if that's what the goal is that a lot of them will give you a specific set of questions. It's not going to ask you to architect this. You're not going to be like, so how would you create this thing? It would be much more of which would be the most cost effective in a particular situation. So if you're taking the exam and you look into this type of storage, what we're looking at is, hey, I know that I have this regular activity, and it's going to be on a kind of a clockwork, and I'm going to access data in a certain pattern. And if you recognize the pattern, then you'll know which one is the best one to choose and which one would be the bad idea. So you'll see a thing like, oh wait, this whole bursting thing is going to cost me way too much money, so I need just to do the provision throughput, and that'll be the right answer. So just kind of pay attention to what the question is asking you in terms of like what the overall like kind of existing design is, and you'll be able to match the right type of throughput for the right cost if it says which is the most cost effective.
And it kind of goes back to what you were saying earlier. Anything faster and with greater features is going to cost you more.
Exactly. I mean, it's true.
To what you mentioned earlier.
It's like EC2. If you want it now, it's going to be more expensive. You want to reserve it, it's going to be less expensive. The faster you want it, the quicker you want it, the more expensive it's going to be. So you need to know the patterns behind the design, and you're not going to know that unless you've actually built some of these things, right? This is why you take the time to like, oh, look at that. This is going to cost this, and this is going to cost that. So a little bit of practice won't hurt.
Definitely, couldn't agree more. Okay, so now we move on to FSX. Again, this is another storage service which comes up in the exam, and this focuses on file systems and comes in two forms. We have FSX for Windows file server and also FSX for Lustre as well. Now, the pricing for each of these options operates in a different way. So firstly, let's take a look at the FSX for Windows, which has 3 price points: capacity, throughput, and backup. So be sure to take a look at those, understand the differences between them. There's no setup fees, but you do pay for the amount of storage capacity that you consume, and this pricing varies between either a single or multi-AZ deployment. You're also charged for the amount of throughput that you configure for your file systems, and at the bottom there you can see data deduplication, and this is a really important point and benefit that you currently get with FSX for Windows over Lustre. And this can be activated for your file system and can save you up to 80% on storage costs, depending on what type of data you're storing. So data deduplication simply means FSX will automatically store duplicated files or portions of files just a single time. And this helps you to save on your storage capacity costs, and it remains invisible to the user that the data has been deduplicated. So it's a really good way to save money when using the Windows version. Then we have, one point to mention on data deduplication, it doesn't add any additional costs as well to use that. The cost associated with FSX for Lustre differs to that of Windows. It offers a much simpler cost model. Again, there's no setup fees, and you only pay for the storage capacity that you need. But Lustre, as I just mentioned, it doesn't offer that opportunity to optimize your costs with data deduplication. But it does offer free throughput capacity, whereas Windows doesn't. Any advice on FSX storage and costs for the exam, Stephen? Or key points to look out for?
I think the key point really is going to be around throughput. Again, kind of that speed of access. But a lot of it, again, you're not going to be asked questions that involve how do you build it. For this particular type of question, if it says cost, you're going to need to know, hey, I've got this thing and I need to be able to back it up. And backups, what's that going to cost for storage? And how much is this going to go? How much data am I putting through it? And maybe is this the correct solution? And recognizing, hey, what would I use instead of this? Would I try to use something with NFS or EFS, or what are my options? Do I just want to store data on the side in S3? And which one would be the most expensive, and which one would be the least expensive in terms of whatever has been given to you? Maybe throughput, maybe overall storage, maybe being able to do backups, be able to take snapshots. Whatever it is, you need to be able to know what it's going to cost you in general, and if it would be a good thing. And it's usually going to be compared to other similar storage things. And so just knowing like where the gotchas are going to be, like for this one, there's no setup fees. That's great. But the storage is priced on the average storage provision per month. Well, that could add up over time. So do I have to have something that would work that I don't have that? And being able to pay attention to those kinds of questions are going to be key.
Yeah, and one question that we get asked a lot as well is, do you need to know actual costs of things? Do you need to know how much it is to store 1 gig of data in a particular region when using EFS? And the answer to that is no. I've never seen any example where it's asked you to confirm how much something costs in a particular region for any service. Have you ever experienced that, Stephen?
There's never in the 9 different certifications I've had over the years, and the 6 or 7 that I have current, I have never been asked any question about a dollar amount. The closest that it comes is I'm trying to figure out one region versus another. And even then, that's just, they're really asking about moving data between the two and not the actual cost.
Yeah, because I think quite a lot of people get a bit heads up about, do I need to know the value of how much this is in this region, or is that more expensive than that to the dollar? You don't need to know that level of detail. Just the principles and pricing methodologies behind these services is what you need to know. Okay, let's move on. So this is the last of the storage services that we're going to look at today, and that's the AWS Storage Gateway. A quick overview of the Storage Gateway. It allows you to provide a gateway between your own data center storage systems, such as your SAN or NAS, and Amazon S3 or Glacier. And it allows you to scale your storage requirements both securely and also cost efficiently. And there are different configurations available. You have file, volume, and tape gateways, and they all come with different price points, as you would expect. Now, I'm not going to run through the configuration of each of these. I just want to point out some of the pricing features for each. So let's start with the file gateways. So as this configuration integrates largely with Amazon S3, much of the pricing is based upon S3 storage costs. So these will relate to the actual storage classes that are being used. And it also uses a local on-premise cache for accessing your most recently accessed files to both optimize latency, but also to help reduce egress traffic costs as well. Now, we also have request pricing, where there's a small cost per gigabyte associated to data written to S3 by the storage gateway. And the first 100 gig is free, and it goes up to, I think, a maximum of 125 gig a month. But any other types of requests, again, are priced as per Amazon S3's pricing. Next, we have volume gateways, and this comes in two flavors. We have the stored volume gateway and also the cache volume gateway. The volume gateway is on the left, cache on the right. So the stored volume gateways back up your local storage volumes to Amazon S3 as EBS snapshots, while ensuring your entire data library also remains locally on premise for very low latency data access. Now, because the volumes are stored as EBS snapshots, they are not charged as S3 storage, even though they are backed by S3. So instead, they are billed as EBS snapshots instead. Now, with cached volume gateways, the primary data storage is actually on Amazon S3 rather than your own local storage solution. However, cache volume gateways utilize your local storage data as a buffer and the cache for recently accessed data, again, to help maintain that low latency. The cache volume gateways are charged on a per month metric of data stored on S3. And again, the request pricing is charged the same as it is for file gateways. Now, the final option with the storage gateway is the tape gateway. So this allows you to back up your data to S3 from your own corporate data center, leveraging the storage classes within Glacier for data archiving for a far lower cost. And there's three different options for storage pricing of tape gateway. So you have S3, S3 Glacier, and S3 Glacier Deep Archive, all of which are charged per gigabit a month of data stored. And generally, if you're using the tape gateway option, you're looking to take advantage of the very low price points of Glacier and Deep Archive, which, as we discussed earlier, offers significant savings, especially when you're using Deep Archive. Now, for any virtual tape retrieval requests being stored on the Glacier classes, you will pay a per gigabyte cost, with the Deep Archive class providing the most expensive retrieval rate. Any request that results in moving your virtual tapes between your different Glacier storage class and an S3 Deep Archive, then you'll again pay a per gigabyte fee for data moved. So basically, the AWS Storage Gateway uses a variety of different storage options from S3, EBS snapshots, S3 Glacier, and Deep Archive. And the cost of each is very dependent on the type of gateway required, which will, of course, be dictated by your use case or the particular question during the exam. To quickly summarize, file gateways pricing is probably the most simplest and essentially follows the pricing metrics of Amazon S3, apart from the request data rights. Volume gateways, again, offer a simple pricing structure, but it uses the per gigabyte metric for volumes in addition to any snapshots of the volumes priced for EBS snapshots. And then the tape gateways offer additional complexity due to the range of storage classes that it can use. So you need to understand the different retrieval times for your data based on Glacier and Deep Archive as well. So that's it on storage gateway. Any points to make between those three different kind of configs on this, Stephen, from an exam perspective?
From the exam perspective, not very many, because I don't think I've seen but one or two questions that come close to the cost aspect of using the storage gateway appliances. Usually what happens is it's kind of behind the scenes, like eventually something is going to get moved to a long-term storage. So knowing that it's something that's available for, like, Deep Archive is available, or moving into Glacier is available as part of the thing. And then that's the cost effectiveness part. It's not necessarily the actual storage gateway appliance. It's much more of what's behind the scenes that is the most cost effective thing for what's happening.
Awesome, thank you. So I think now, Stephen, I think we've covered the first subdomain point. Yes, we have, which is good. So now we can move on to 4.2, identify cost-effective compute and database services. So I want to start with compute and highlight a number of pricing options that are likely to come up during the exam. I think I've seen a lot of these referenced, and a lot of these pop up in different questions across different exams. So you need to be aware of these and how they operate. So make sure you spend some time looking into them and their use case as well. So from an EC2 perspective, there's a number of different purchasing options, including on-demand, reserved, scheduled, spot, on-demand capacity reservations as well. So you can purchase EC2 instances through different payment plans, and these have been designed to help you save cost by allowing you to select the most appropriate option for your deployment, and you'll be tested upon this as well. So by having an understanding of these can really help you save a considerable amount of money depending on the use case. And like I say, I want to reiterate, this is essential during the exam. So on-demand instances have a flat rate, which is determined on the instance type selected, and it's paid for by the second. On-demand instances are typically used for short-term use cases where workloads can be irregular and where workloads can be interrupted. When you stop or terminate your on-demand instance, you'll stop paying for the compute resource. Something to bear in mind. Now, reserved instances allow you to purchase a discount for an instance type with a set criteria for a set period of time in return for a reduced cost compared to on-demand instances. Now, this reduction can be as much as 75%, so that's far better from a cost perspective, depending on the use case. They must be purchased in either a 1 or 3 year time frame, and again, further reductions can be achieved when using reserved instances, depending on which payment method you select. And there's 3 different options. You have all up front, where the complete payment for the 1 or 3 year reservation is paid, and this gives the largest amount of discount. Then you have partial upfront, where you can just make a smaller upfront payment, and then a discount is applied to any hours used by the instance during that term. And then finally, no upfront. So you basically don't pay any upfront or partial payments, and this provides the smallest amount of discount when using reserved instances. Now, scheduled instances are similar to reserved instances in the fact that you pay for the reservations of an instance on a recurring schedule. Now, these are more cost effective than on-demand instances. And something to be aware of when using scheduled instances is that they incur a charge even if you do not use that instance during that time allocated. Then we have spot instances. They allow you to bid for unused EC2 compute resource. However, your resource is not guaranteed for a fixed period of time. To get your resource, you must bid higher than the current spot price, which again fluctuates depending on supply and demand of the unused resource. Now, if your bid price for the instance remains higher than the spot price, then you'll purchase that instance and you continue to use it. But as soon as your bid becomes lower than the fluctuating spot price, then you'll be issued a 2-minute warning before that instance will automatically terminate and is removed from your AWS environment. Now, the big bonus for spot instances is that you can bid for large EC2 instances at a very low cost point, saving a huge amount of cost. Then we have capacity reservations, which allow you to reserve capacity for your EC2 instances based on different attributes such as your instance type, platform and tenancy, etc., within a particular availability zone. And this capacity reservation could also be used in conjunction with your reserved instances discount, providing you, again, additional savings. What would be your kind of key points to take away from EC2 pricing, Stephen?
So from my perspective in the exam, it's rare that you see a question about a specific thing, like like on demand versus reserved instances versus scheduled instances. It's in the world, in the way that we operate, is that you need multiple types at once. So you need to run some workloads with reserved instances, and you need to know how many are running for how long a period of time for that to be a break-even cost. And the rule of thumb is that a reserved instance pays for itself if it's running, because it's in a 1 or 3 year term, if it's on 24/7 for half of the time that's available to it. So like if you're running a 24/7 workshop or 24/7 compute, and you know that you're going to be on and running for more than 50% of the time. So in a year lease, it's 6 months. For a 3-year lease, it's a year and a half. If you know that you have 24/7 work, then it's going to pay for itself. It's going to be cost effective. However, there are going to be some types of workloads that are spiky, that are going to be intermittent. And if you can plan for them, then you need to be aware of how do you get around those needs. Is it spot instances? Is it what happens if the job gets terminated? If it's work that won't necessarily survive a reboot, or when it starts, does the job have to finish? In which case, that's much more of an on-demand kind of thing. So you really need to pay attention to not only how much they cost, but what do they do and how do they work together, so that you can build like the most cost-effective solution. So some things are always on, some things I can turn on when I need them, and some things are going to be a scheduled, like every Friday night or the last Friday of the month, I need more compute power to run my end of month billing or end of month whatever. Well, then that kind of workflow means that I have, like, something's always on, I've got something scheduled, I've got spot when I need them, and I put all the pieces together to make one big picture. And it's that big picture that is going to be on the exam.
Some really good insights there, Stephen. Thank you. Okay. Where are we up to now? Database services. Okay. So let's now look at some of the costs associated with RDS and where you can expect to both save and incur costs. So RDS has a wide feature set that you won't be surprised to hear has a different cost model for each function. For example, your purchase options, your database storage and IO, backtrack, backup, snapshot, export, and data transfer. So let me just quickly run through each of those at a high level, because having an understanding of what each of these features are and how cost is measured is well worth making a note of and just taking a few minutes to familiarize yourself with. So the database instance purchase options gives you, again, different payment plans. For example, variations of on-demand or reserved instances, or even serverless. Now, not all database engines support all purchase options. For example, bring your own license plans are only supported by Oracle, and serverless only supports Aurora. So be sure to look into the differences between these plans to ensure you understand how costs differ and where you can save money in different scenarios. From a storage perspective, MySQL, Postgres, MariaDB, Oracle, and SQL Server all use EBS volumes for both data and log storage. However, Aurora, on the other hand, uses a shared cluster storage architecture, and so it doesn't use EBS. Now, RDS supports 3 different types of storage, these being general purpose SSD, provisioned IOPS SSD, and magnetic as well. And each of these offer different price points and performance, and you need to understand the differences here and when you'd use one over the other. Again, you kind of flip between either general purpose or provisioned IOPS. And when you start adding provisioned IOPS and more advanced features, it's going to cost you more. Now, Aurora is slightly different. It uses a shared cluster storage architecture, which is managed by the service itself. Now, when configuring your Aurora database, if you're using the management console, then the option to configure and select storage options doesn't actually exist. Your storage will automatically scale as your database grows. So as a result, the pricing for your Aurora database is priced on actual storage used, in addition to the number of IOs processed. So that's the great thing about using Aurora, is that you're only billed for the storage used and the IOs processed, whereas with MySQL, MariaDB, Postgres, Oracle, and SQL Server, you are billed for the storage provisioned, regardless of if you use all of it or just a part of it. So now moving on to Backtrack. So this is a feature that is only currently available for the MySQL compatible Aurora database, which allows you to go back in time on the database to recover from an error or incident. And the pricing is based upon the number of changes recorded made to the database in your Backtrack configuration, which can be up to the previous 72 hours. So essentially, the longer you want to backtrack in the event of an incident, the more it is going to cost you, because RDS needs to retain copies of all those transactions in that time period. Now, when it comes to backing up your storage, you might be surprised to know that RDS does not charge any backup storage costs that equate to the total sum of provisioned storage used with your databases within a specific region. However, any storage used over this free tier is chargeable. And RDS snapshots are essentially backups of your database tables and instances, and these snapshots can then be exported out of Amazon RDS to S3, for example. Perhaps if you want to perform analysis of the data held within your database. However, this export process does come at a cost, and you can also encrypt your export using KMS, which will also incur additional KMS costs as well. Not forgetting any S3 put requests too. Okay, so I think that's it from RDS. Any pointers or gotchas here, Stephen, you want to point out?
Most of the costs that you're going to see, or cost requests, are going to involve like saving data, backups, and the like. It'll be less about the engine and more about storage. And one of the tricks to storage is that, and they just relatively recently, they now have this auto scaling storage for some of the RDS instances, is that data scales up in the database. It doesn't really scale down. Once you add to it, you can't really remove it. I mean, you can, but it's a process, right? You actually have to, it doesn't auto scale down. You do that yourself. And so when you start to see costs increase, and you're like, what's going on? And why didn't the cost go down? It's because you need to pay attention to the size of the volume. And if you need to shrink it, then you need to do that. Or the number of snapshots that you have, or the amount of data that you're keeping in your database. Every now and then you see some things about, oh, I've got this ingress cost, and that's more of a network cost, and which we're going to talk about a little bit later. But just be aware that databases don't like being shrunk. They like growing. They're okay with growth, but you need to pay attention to how to make it shrink when it's time to do that.
Yeah, that's a really good point. I also realized I missed out just giving a quick overview of the data transfer as well here, so apologies for that. So just quickly, when we talk about data transfer, there's a number of different paths where you might be charged for transferring data either into or out of RDS, depending on the source and destination. For example, any data that's transferred out to Amazon CloudFront is free. However, if data is transferred from RDS to another region, then there's a cost. So it might be worth taking a high-level look at data transfer costs as well. Following that, I'm kind of done with database costs, so let's move on.
Yeah, and we're going to talk about data transfer
Okay,
in a little bit. We have in 4.3, so yeah. So we'll don't worry, we'll cover the concept.
go for it, Stephen.
Oh, look at that! Speaking of 4.3, so there's a
Go for
lot to talk about
it.
in a
As if by magic.
as if by magic. A lot to talk about here, and this one I think one of the places where you start to see more cost discussions in the questions. So just like anything else, the more you use it, the more expensive it is. And if you know how the system is built, you know how to get around some of these costs. For example, if I want to move data to CloudFront, now the CloudFront being the edge location, if I move data to that, then there's no cost to move data from S3 to CloudFront. The cost then gets moved into CloudFront and pulling the data down from there. So if I move my data closer to my customers wherever they are using CloudFront, then that could be a potential savings um, for whatever workflow that you've got. Um, so Direct Connect is another thing that is a kind of a trick, and this is kind of a funny thing, is that AWS, if you look at the documentation around AWS Direct Connect and how it works, they talk about all of the things it can do. And even it says here, reduce network costs, increase bandwidth, provides consistent network performance. Yeah, what it really does is it provides consistent a baseline of network performance that you can count on. You're no longer at the mercy of the public internet. It's less of a cost savior than it is hey, I have dedicated bandwidth in and out of AWS. However, what you can avoid with using this is some of the peak flow, or you can make sure that um, you can plan for regular movement of data, and you know exactly what's going to happen when it's going to happen. And so those are the benefits. If you want a resilient connection, that's the thing. And if your business, the costs are determined on whether or not you can perform, and you need resilient connections, that's the thing you're going to get from Direct Connect. The VPN, AWS VPN you can establish a secure and private connection between your corporate network and the AWS infrastructure. Lots of different ways to do this, but you have to pay attention to data in and data out, right? These connections are metered, but when it comes to the exam, there's not a lot of questions about how much does it cost to do this. They're usually more about, hey, I need to secure it, because the general thing is really around VPC endpoints and gateway VPC endpoints and the private link. So, and this is true of most network stuff. So if you think about, even with RDS, when we were talking about transfer costs, if I'm in a region and I have EC2 instances and I have an RDS instance and I've got them connected to each other, the transfer cost between the two of them, there's no charge to move the data back and forth. It's already inside the AWS network. They don't really care. It's when I pull it outside of the region, when I pull it out of AWS, then at that point, there is going to be that I'm crossing the border. I'm using the AWS hardware to manage the egress. And as soon as I kick in that, there's a cost. Now, if I use an endpoint and I go between, and I try to like fake it between regions, and I use that, then I'm not going to hit the public internet, and I'm going to have less cost or no cost depending on how I manage my data retrieval. The idea here is that I want to avoid hitting the public internet as much as possible to maximize or to minimize my cost, to maximize my savings. So like with an endpoint, so if I can create an endpoint to a service, then so the Gateway VPC endpoint supports Amazon S3 and DynamoDB. Without the endpoint, what I have to do is I actually have to send it through an internet gateway, which means that I'm going to get close to the public internet. And if I go from region to region, I'm going to have an egress cost. If I use the endpoint, then I'm just going to plug right into the Amazon network, go right to my data and pull it out. And I'm only have data. I'm not going to have data transfer fees. I'm going to have just the data storage. When the data lands on S3, that's the cost. Now, the last thing that I kind of want to mention here is that inbound data doesn't have a cost. I mean, AWS doesn't charge you to put data in it. It charges you once you've put the data there. Once the data has been stored, like in S3, that's when costs are incurred. So if I pull data out across the internet again, there's going to be a charge. If I go from region to region and hit the public internet, there's going to be a charge. I'm going to have an egress cost. However, if I can skip that, if I can do some VPC peering, if I can do some, which would be inside a region, if I can manage my costs and not hit that internet gateway, egress costs won't be there. Let's see, there was something about RDS that I was going to bring back up. Oh, so again, if I'm sending data to an RDS instance, and that RDS instance is in the same region, but all I'm using is the public internet, as soon as I send the data there, not a big deal. But pulling the data through it, again, I'm pulling data out of, I do the request, I get data out of the RDS instance, there's going to be some network cost, that egress cost. What I want to do is I want to make sure that I avoid using the public internet, which is a good thing in general, right? I mean, the public internet is really safe. I could just like leave all my data up unencrypted. Who really cares? No, that's not true. That's never been true in the history of the public internet, the commercialized public internet. That's never been true. So if you can avoid that, not only do you make it secure, but you make it cost effective by minimizing egress costs. Am I missing something, Stu? Is there anything else that I should add here?
No, I think you covered that really well there, Stephen. Yeah, give a great understanding through all those points, so thank you very much. Yeah, I don't think I have anything else to add. I think you touched on all the points that I would have said.
Yeah, I think that, I mean,
Okay.
you have to remember that between availability zones in a region, inside, as long as the traffic stays inside, you're okay. You're not going to hit any extra charges. I mean, it's not like if you're going to go.
Yeah, if it's inside, it's more secure as well.
Yeah, and you're not going to double dip, right? I'm not going to charge you for storing and charge you for network traffic between the devices that are already in your VPC. What I want to do is I'm going to, if it's going to be inspected as it comes out, that's when I'm going to look. That's when AWS is going to charge you.
Excellent. Thank you, Stephen.
Certainly.
Okay, so we can move on to our Q&A. Let me just have a quick look at the questions that have come in. So have one here. Hi, Stuart. For spot instances, is there a minimum time, let's say 1 hour minimum, allowed to be used before AWS starts terminating the instance due to cost fluctuation? So there are, with spot instances, you can reserve the spot for, I think, up to 1 to 6 hours, but you do pay a premium for that ability. I think it's called spot blocks. So you can essentially reserve that spot instance for 1 hour or 2 hours, up to 6 hours. But if you don't do that, then AWS, as I understand it, can take it away from you 15 minutes later. And I think for any partial hours used, you don't get charged for. Correct me if I'm wrong, Stephen, but I think that's correct. So I think AWS can take it away at any point unless you do activate spot block.
So I think you're right, but I think when they moved to the reserved or the spot instances, there was something it was when they did per second pricing. When it was per hour pricing, it was an hour minimum, but now they can give you a 2-minute warning right out of the gate. You can get, it'll just happen. Like you could be running for 30 seconds and suddenly the price jumps, because remember, this is unused capacity. And if there's a large demand, suddenly there's like, hey, there's something big is happening and everybody wants it, AWS is going to take it back. So you can't count on it.
Yeah.
Now with the spot block and there's another, it's a relatively new thing. So it's not probably going to be on the exam yet, but it's probably going to come, is that you can, when you do this kind of reservation, you're going to pay a premium for that. But by that, when you look at it, it's like you're really just buying a reserved instance for a really short lease, but you're going to pay more. It's just, I don't know if it's, I have mixed feelings about it as far as it being worth anything, but I'm sure there's customers that have asked for it. So I guess the short answer is there's not really a minimum unless you pay for it. And I'm not sure that the cost
Yeah,
effectiveness
that's basically it. Yeah. So you just need to make sure that whatever you're running on those spot instances, those workloads can be interrupted without causing anything to fail. If you do have workloads that can't be interrupted, then you need to look at something like either on-demand or reserved instances. I think the next one, Stephen, is kind of falling in line with what he's talking about a moment ago with regards to data transfer and RDS.
Oh, yeah. So somebody's asking data transferred between EC2 and RDS instances in different availability zones in the same region. Totally cool. It's one VPC, it's one big network space, and what you have is the ability to send data to from EC2 to RDS. Now the network charge won't exist. However, RDS, I have to remember how all of it works. There's depending on the engine and depending on the class, I think that there's a charge for like compute, like egress in general. It's not, but it's it's an RDS cost. And I'd have to look that one up because I don't remember that bit right this second. But the network charge, because it's internal, there's not going to be a charge. So I will make a note and I will I will try to figure out what the exact answer to that question is.
Okay, we've also had a question here. In the exam, will there be any labs to complete? And is there an insight as to how many labs? At the moment, AWS don't have any labs in their exams. So I'm not saying there won't be any in the future because they're kind of adapting and changing exams all the time. But at the moment, there's no hands-on labs kind of questions in the certifications. Have you heard of any talk of that at all, Stephen, coming along?
I've only heard whispers. You look at the internet and they're like, hey, we want to do this and they want to do that. I don't know. I do know that AWS looks at ways to improve all customer or the experience or all aspects of the customer experience. So it wouldn't surprise me if they do some practical things, but I haven't heard anything like in the near future.
No, same. So I don't think that's coming for a little while, yet. Another question here. On the exam, are there any questions which test your knowledge on billing by the hour or month or unused hours or seconds usage? No questions that are going to ask you the exact price, but you should be aware that, for example, EC2 instances are billed by the second and not by the hour, but you won't be asked how much that is. That's pretty much as deep as it goes from that perspective, as far as I've experienced across the different certifications. It doesn't really go any deeper than that, does it, Stephen?
No, and that would be you'd be pushing it to get even close to that. It's really just how does this thing work, and and what would be the cheapest thing, and would it be spot instances, would it be reserved instances, would it be using Glacier? It's not, well, you know what, you use this spot instance for 10 minutes, and no, nobody cares. I did real quickly, I did pull up the how am I charged and billed for use of Amazon RDS. And according to their website, it says you pay for what you use, which I knew. There are no minimum setup fees, know that too. You're based on database instance hours based on the class. You're charged on storage, gigabytes per month. There's a number of IO requests per month that you can get billed on for when you use magnetic storage and when using Amazon Aurora. Provisioned IOPS, which I probably should have mentioned. I should have probably had you put in the slide. So if you get a high-speed disk IO in your instance, in your RDS instance, you're going to pay extra for that. Backup storage. So these are you get storage. You get snapshot-based storage for free based on the amount of data that you're paying for inside RDS. So if you have provisioned a 500 gigabyte database volume, then you're going to pay, you pay for that storage, and then you get a snapshot amount of snapshot space equivalent to that 500 gigabytes. If you take your own snapshot, a manual snapshot, and it sits next to that database and everything else, you pay extra for that. And then it says that you do pay for data transfer, but it's for internet data transfer in and out of the DB instance. So that's where it comes from. It's if you're going to access the database through the internet gateway, you're going to have a charge. It's not necessarily charged per access. That was probably something from my youth, my misspent youth when I first started on it on AWS.
Excellent, nice one. Thank you, Stephen, for checking that. So we'll take one final question, just because of time. Can there be questions on Redshift in the exam? You might see Redshift come up, but from memory, you aren't really tested on its configurations or the workings of it. But you should certainly be aware of what Redshift is. But I don't think you'll see many deep questions into how to configure it or set it up for any kind of high availability or backups or anything like that. Did you experience much on Redshift when you took the exam, Stephen?
I really just want to say no, right, and be done with it. However, those
never say no because we don't have all the questions, but
yeah. Usually stuff like that shows up as a
just be aware of what it is.
Yeah, it's a distractor. Definitely. You might see SageMaker. You might see somebody might throw in well, you know what we're using? What's something else obscure? The IoT core. Yeah, who cares, right? It's a trick. Nobody really cares about IoT core. What they're asking you is how do you get data in and out of it? Oh, and I've got this endpoint, and that the question is about the endpoint, not about IoT core or Redshift. Or the question is about S3, even though it has the word Redshift in there, it's there to make your like palm sweat and you break out in hives because I don't know that. You have to learn to ignore some of that stuff that shows up.
Okay, so if you are looking to take the cert, then we do have our learning path here at Cloud Academy, which covers all the different domain points and subdomains. So please check out the courses, the hands-on labs, the related blog posts, and also our preparation exam. So that just brings me to the end. So thank you. Again, thank you to everyone for joining us today. And again, a special thanks to you, Stephen, for joining me to cover the topics across Domain 4 today. It's been really great having you on the call. And don't forget, you can check out all of our existing webinars at cloudacademy.com. Do you have any closing remarks, Stephen, before we go?
Don't freak out about costs in the exam. There's only a half a dozen, or a half a dozen. There's only a handful because it's only 18% of the overall exam blueprint. And most of them are just really common sense. How do you minimize your expense when you build something? Because it's really easy to make something expensive. So how do you architect it in such a way that you can make sure that it's cost effective? Because you don't want to give Amazon money that they don't need. You keep your money, it's yours. You earned it.
Excellent, brilliant. Well, that's it. So thank you again, and thank you, Stephen, and thanks to everyone joining. I'll speak to you again soon.
Thank you, Stu. Cheers.
Cheers.